The review is, but this isn't. Okay? So please check along with me. So this is what we needed to work on, yeah? I want to know how far it was from Sandra up to Elizabeth. Well, I already knew this was 130, but I didn't know this side, right? So this red triangle here, I needed 2 pieces of information. So I needed this right here, didn't I? Because there's x, there's an angle, but I needed this side right here. Right? I can get that side from this triangle on the bottom. Right? So if I call that y, because I needed y, I've already called that guy x. How will I find y? Well, to find y, I need to use this triangle. Right? And that triangle, like all trig questions, we do the same thing. Is there a theta? Yes, it's 40. What is that compared to 40? Opposite of 130. And I needed adjacent. Was y. What uses O and A? Tan. So tan 40 equaled 130 over y. Y was on the bottom. So y equaled 130 over tan 40. And that gives me a number, whatever number it is. $155, right? It's 154.9. Yeah? So now I know what y is. So now up here, where's that calculator that you're going to buy? Up here now, I know what y is. Yeah? So now all I got to do is find x. And I do, just like all math. It's a pattern. Now I have a new triangle. Now I am working with this yellow triangle. And it has a theta of 10 and adjacent of 155 and an opposite of x. Again, it's tan. Tan 10 equals opposite x over 155. Numbers on the bottom, so it's 155 times tan 10 to get x. To get x to be 27. Now you guys are smart kids. That's 27. This was 130. When I add them together, I get 157, don't I? The question isn't how many feet, it's how many floors. 10 feet per floor, so it was 16 floors. If you got 157, do I still give you full marks? You did the trigonometry part right, so you would get 90% on the question, yes? Because the question asks how many floors, right? So do you get your A? Yes. But did you do it perfectly? No. That's where you get the last, couple of percent to get 100%. Does everybody understand?
No, I just want 155 divided by 10.
Why would you divide by 10?
I don't know. I'd still
You
get
have to
16.
But you have to do 155 times tan 10. But there's your 155 times 10 tan.
Because I just did that.
Yeah. And there's your 130 divided by tan 40. You did it all right. I don't know what you did here.
I don't know.
Me neither. So you got to work on your work. Right? You drew a beautiful diagram.
I did.
But your trig, that's the part I need to see, right? I can't help you with what you did wrong when I can't understand what you did. Do you understand what I'm saying?
Yes, sir.
So it's a great drawing and you seem to have the right answer. But somewhere in there, I don't know how you got it. So I don't know what you did wrong because I can't follow your work. Understand? Guys, oh yes, Parm? Yes, I will do that in 1 second. Guys, I cannot stress this enough. Those of you that came from another country where they care about what your work looks like, your work is always fine. I can follow it. Those of you that are from Canada, where you were allowed to basically vomit on a page, and if some of the numbers are right, your teacher is desperately looking to try and get you the marks, that's fine. But let's remember, math is getting more and more complicated, correct? You are getting less and less comfortable doing the math, right? More and more often, you are asking me questions like Sean just asked me, which was, where did I go wrong? You've all asked that question, right? If you bring me a sheet of paper that has writing all over it, and I say to you, well, what did you do here? And you say, I don't know, I just started writing stuff down. Can I then tell you where you went wrong? It's impossible for me to help you. So you've got to try. Notice when I do work, I don't just write it everywhere, do I? I follow an order. You got to start doing that if you want me to be able to help you answer that question, which is where did I go wrong? You have to show me. Now, in a lot of other places when they do math, they do it in a very specific way. You follow this. And that's what it used to be like when I was your age. But now it's not like that anymore. Now we're just happy if you do work. It's the same reason why your teachers didn't care in grade 3 if you spelt things wrong. They would let you go on that. You can't do that in math because I don't know where you went wrong if you can't follow your own thinking. Cool? Now, Parm just asked how you know whether to add or whether to multiply or divide, right? I'm going to show you again. Please watch. If I gave you this question, 5 equals x over 2, and we were doing algebra from grade 9, your job is to get x by itself, yes? Okay. So to get x by itself, you have to move every other number away from x. When you're doing algebra, you do the opposite of what you see, right, Parm? So what is the opposite of divide by 2 to move away this 2? I got to multiply this side by 2, and I got to multiply this side by 2. And now I get 10 equals x. Okay? Now, what if I gave you this? 5 equals 10 over x. Now I have to get x by itself still, but it's at the bottom. So I got to move that x because I don't want them on the bottom. So I multiply by x. Cancel, cancel. Now I get 5x equals 10. Then I divide by 5. X equals 2. Now you can see at the end, I ended up doing 10 divided by 5, right? So if you understand algebra, it's not a question of when do I divide and when do I multiply. You're just doing algebra. If you have trouble with algebra, then you just got to memorize. If it's a denominator that is a number, you multiply. If it's a denominator that is a variable, you divide. Okay? Just think of this. That's all you got to remember. Right? If you can do that, because the only thing that's different here is this isn't 5, this is now sine 5, isn't it? So this down here is 2 times sine 5, or this is sine 5, so this becomes 10 divided by sine 5. Okay? Cool? All right, everybody good? Now remember, Parm, also, if you show me the right work, but your calculator gives you the wrong answer, I'm still giving you 2 out of 3 anyway, right? Because that's just screwing up your calculator. Oops. Everybody cool? Okay. So, here's my triangle. Now remember, to do trig, we need a triangle, yes? So I have a triangle, but is this the right kind of triangle to do trig with? Why? I need the line down the middle because I need 90 degrees, don't I, actually? So if I slice that in half, does that give me my 90 degrees? Everybody remembers to do that almost all the time, but here's what they forget. How long is this? It's 6. But when I give this to you on a test, a bunch of you are going to tell me that's 12. Because you're going to forget. Because for whatever reason, right? There's a million reasons for it, but you're going to forget. So this, I need this angle now, yes? Because I need the angle of inclination. So my theta, I don't know what it is, but what do I know? What is this 6? Opposite, adjacent, or hypotenuse? It's adjacent. What's this 8? Hypotenuse. What uses A and H? Cos. So cos, but I don't want cos, do I? Because I need an angle. So what do I need? Shift cos. And it's which goes on top, 6 or 8? 6. How do I punch that into my calculator? Because that's the hard thing now, isn't it? Everybody is starting to understand SOHCAHTOA. The hardest thing now is to make your calculator work because everybody has a different calculator, or worse, you bring a different calculator to every class. Oh my God, I forgot my calculator for math, so I'm going to borrow Jimmy's. And it's not the one you're used to using, and then you screw it up. So learn how to use your calculator. Depending on the calculator, it's either shift, cos, bracket, 6 divided by 8, bracket equals, or bracket 6 divided by 8, bracket, shift, cos. And then it might need an equals or it might not. And what is your answer? 41. And that's perfect. Is everyone okay with that? Once, twice, thrice? All right. Now, number 11 I told you was exactly like number 9? 19. So, from the roof of Ye's building. So I need to draw one building. There's Ye. Cool? From that roof, the angle of elevation. Where does elevation go? Up. So Ye is looking up to another building. Everyone agree? Now, have I made an angle yet? I need to add this in, right? Now I have an angle. Where's the 37? Is it there, on the top, or down here on the left? Why do you know it's on the left, L? Because it's an angle of elevation from Ye. Okay? It's 37 degrees. When he looks down to the bottom of the building, so now he's looking down at the bottom, it makes 28 degrees. The buildings are 21 meters apart. Where does the 21 go? In the middle. So now I have two thetas, and I have an adjacent for both of those thetas, don't I? What do I need? I want how tall the other building is. So I need that, and I need that. And then what am I going to do with those two? Add them. Before I even do any trig, I look and I see what I need to do. I have two triangles, I have to find two opposites, and I have an adjacent. What uses opposites and adjacents? You know it's going to be tan. So, in triangle 1 and in triangle 2. In triangle 1, do I have a theta? What is it? 37. I have an adjacent of 21, and I need an opposite of x. So I'm going to use tan 37 equals opposite x over adjacent 21. Parm, is this multiply or divide? Multiply. Why? Denominator's number. So this is going to be 21 tan 37. Cool? Now, if you were me, what you know about me, I've talked about this before. Do I go to my calculator here? No. Why? The less times I go to my calculator, the less times I have to screw it up, right? I know that's this answer. So I'm going to leave it alone because I've shown my work. Now I'm going to go over to triangle 2. Do I have a theta? What is it? And my adjacent is still 21, and my opposite is now y. Tan 28 equals opposite y over adjacent 21. So this is 21 times tan 28, isn't it? Have I gone to my calculator yet? Still not, because it's the calculator that's causing you guys issues, isn't it? That's what makes trig hard. Because when I did this example, 5 equaled x over 2, everyone could follow it, right? So the only thing that's making this any different is throwing in the calculator. So here it is. I know I have to add these two, so what do I do here? Add. And now I go to my calculator once. If I have a forward calculator, I punch in exactly what I see. 21 times tan 37 plus 21 times tan 28 equals. And you get an answer. If you are still rocking the backwards calculator, I have two things to say to you. One, if you still can't do trig, you need to do one of two things. Get a different calculator that's forward so you can write in what you see, or B, actually learn it. Don't tell me you can't learn how to punch buttons, because I've watched every single one of you spend my whole class texting people. So don't tell me you can't learn how to push a button, because you all can work your phone. You all know how to post something to Instagram. That's button pushing. Did you learn how to do it? Yup. So all the horse crap about not being able to learn how to do something like that is just that. Horse crap. Because if you can play Call of Duty, you can push buttons. So if you have this backwards in a backwards calculator, then you just reverse it. 37 tan times 21 plus 28 tan times 21 equals. And what is the answer? Kirsten. Maybe. Okay. 26.9 meters. All right. Last question. Two boys are standing at the same elevation on opposite sides of a mountain. Guys, mountains are what basic shape? Triangle. Does it matter how you draw it? No. Triangle. Done. Boy 1 is over here. Boy 2 is over here. I want to know how far they got to walk to meet at the top of the mountain. Where are they going to walk? Are they gophers? Are they digging through the middle and then climbing up here? Where are they walking? Up the hypotenuse. Hey buddy, hey brah, what's for lunch? I don't know. Let's order pizza. Oh, but we're on top of a mountain. So, you need to find two whats? Two hypotenuses. But how do you find a hypotenuse? There's no 90-degree triangle there. Oh my good gravy, yes there is. How far apart are those boys? Do you know? You do not know how far apart they are, but you do know that the mountain is 1350, don't you? Do you know this guy's angle? What is it? 65. Do you know this guy's angle? 50. So, do you have, for boy 2, do you have a theta? For me, what is it? It's 50. You have an opposite of 1350 Please notice all my ink is disappearing because this computer sucks. And my h equals y. Yeah? Okay. What about boy 1? Does he have a theta? 65. Does boy 1 have, he has an opposite of 1350, and he needs a hypotenuse of x, yes? So what uses O and H? Sine. So boy 1, it is sine 65 equals O, 1350 over x. This guy is sine 50 equals O, 1350 over y. Divide or multiply? Divide. 1350 over sine 65. There's a reason I do practice. I am getting tired of hearing you guys say, how do I get the right answer there? And when I get to this question, I say, okay, guys, what's the right answer? Nobody picks up their calculator. You all wait for me to write it down. How does that help you? Doesn't help you even a little bit. Why do you think I write this work out? So you know what work to do. Watching me write this down wouldn't help. I could write down 312. Would that be right? No. Would you write it down? Of course you would. Because you're not actually doing your work. What is this answer? I don't know. This answer is 1350 divided by sine 50. I don't know. And that is where I want to start leaving this. Because I know how to punch this in. You guys need the practice. What's the answer? For which side? Boy 1 or boy 2? For the 50 was 1762. And how far is this guy got to go then? 1489. Sounds about right to me. Cool in the gang? All right, now yesterday I asked that be finished, right? And I asked you to move on to attempting this review that is in your books, but I told you don't do 5 or 8, right? That's what I wrote on the board in red yesterday, yeah? So right now I should be able to mark 1, 2, 3, 4, 6, 7, and I think it goes up to 11, doesn't it? 9, 10, and 11, right? I should be able to mark that, but this isn't my first rodeo. I know that there are people that don't have that done. So here's what I'm going to do. I'm going to explain how to do 5 and 8 now, so the people that are done everything will now, in a moment, have something to do. And the people that aren't done everything they were supposed to already do can just go back and finish that and then do 5 and 8 as well. Everybody cool? All right. Now, do not bother going to number 5 right now, because I'm not going to do that actual question. I'm going to show you how to do it. Okay? Everybody with me? So the first thing we're going to do is this. We're going to work on this is how to do number 5 from your review. Do not write down what I'm about to write down. I want to show you it, okay? You guys have already seen this question. 90, 90, 62 degrees, 8, and I want you to find, this is 12, no, this is 64, and this is x. If I want you to find x, you don't need to write anything down. Just talk to your neighbor for a second and see if you can come up with an agreement on how you would go about finding x. You do not have to find x. What would you do in order to get to x? Everybody take a moment and talk. Even if you think you know what you're doing, then maybe your partner doesn't. Just talk for a second and tell me what you would need to do. If you don't feel like talking about it, then just figure it out yourself. Brianna. Sorry.
Hypotenuse of it, and then from there you have enough information to get x, the adjacent.
Yeah, because I don't think we're going to get, we'll see what happens, but yeah. Okay, so did we come to an agreement? Here's what I'm looking for. You had to do something with this triangle in order to get this triangle, didn't you? Right? You use one triangle to find the other. Now, here's the next question. Does it matter where this second triangle is? Here is what I mean by that. I could draw this picture on this flat piece of paper, couldn't I? Right? And you could all do the math for it, yes? Everyone agree? What if I did this? Does everybody agree that I have made a 90-degree triangle? Could you do trig with that triangle? Yes, you absolutely could. Now, the thing I have just done, what I drew, was this, wasn't it? One 90-degree triangle there and another one attached to it here, yes? Does everyone agree? If I can do trig on this triangle, I can do trig on this triangle that's attached, yes? Now watch. Could I still do trig on the triangle that is on your right if I moved it this way? Can I still do trig on that? Yes or no? Of course I can, because this side is still in use, isn't it? So dimensions don't matter. 3D or 2D doesn't matter. Do you understand? So when you were doing number 5, there's a plane, yes? Where do planes normally live? Up in the sky. So there's a triangle from ground to plane, yes? That's not a triangle yet. What makes it a triangle? That, correct? The plane is this far away, isn't it? Okay. But are you able to measure that distance right now? No. Why? Because you don't have somebody who's jumped out of this plane with a tape measure, do you? Do you know how high that plane is? No. So you can't do it. Okay? But what if you had a buddy standing on the ground right there? Can you find out how far that guy is away from you? That's measurable, isn't it? So if you know that distance and you know an angle, can you then find out how high the plane is? Okay. If you know that distance and you know that height, can you then find out how far away the plane is? How? Trig or Pythagoras? Everybody got it? You have to think in all three dimensions. It's really hard to draw, though, isn't it? So be careful when you're drawing. If you can't think in three dimensions, you need to remember if there's three dimensions, there's two triangles, isn't there? Because there's one that goes left and right, and then there's one that goes up and down. Yes? Everybody with me? You understand what I'm saying? This should help you with number 5. Because remember, there's 3 directions when you are doing distances in the world. There's how far away it is on the ground, and then there's how far up or down it is. Understand? Everybody with me? That's how you do number 5. I'm going to shut up about it and let you guys try it a few times. But not right now, because I also want to show you number 8. Number 8 talks about this. A boat leaves on a heading. Okay? This is what heading means. And this will also help with number 5. You guys have heard this before. You've seen movies, right? They talk about headings and bearings and things like that. This is what this means. It's direction. So what are the 4 directions that we have? North, east, south, west. North on a map is always up. It's not up in real life, is it? Because what's up? If I stand up, have I moved to the north? Of course not. We decided this. If that's north, what's this? East. This is south. This is west. Yes? Okay. How many degrees are right there? 90. So north is considered 0. East is considered 90. South is considered 180. And west is considered 270. So if I tell you I'm about to walk at a bearing of 90 degrees, in what direction am I walking? Directly east. Do you understand? Does everybody understand? What if I tell you I'm going to walk at a direction at a bearing of 135 degrees? Where is that? Southeast. It would be down here at 135. Does everybody get it? You with me? Okay. We start at 0 and we go up like a clock. 90, 180, 270, back to 360. Does everybody get it? Now, here's where we do trig with this. Because this is real life trig, right? This is how, you know how when a plane goes down and they say the searchers are out looking for it, and how the ocean is really, really big? This is how they find out where to look. They aren't just out there, no plane. They know where to look because they're doing this. Everybody cool? So, I'm going to ask you, if I walk at a bearing of 23 degrees, where would that be? I start at 0 and I go up to 23, yes? So that would be, I go this way, 23 degrees, right? So that means here's Mr. Myers walking off here at 23 degrees, yes? Now you guys are smart kids. I can't do trig there yet, can I? So I don't have a triangle. But if I do this, do I have a triangle? Or can I make this triangle? 57 degrees. Can I make that one? Yeah, because 23 and 57 equals the total of 90. Is everyone cool? Everybody with me?
Doesn't that make 80?
23 and 57 does make 80. Sorry, it's 67. Thank you.
Can she write a test?
Of course you can.
That's what I figured.
You can have the comfy chair at the back. Just move the milk crate.
Don't start writing until I say go. But you can start reading.
Yep. What class you doing, Kashish? Nice. So is everybody cool with directions there? That's the first part of it. Okay, so everyone's cool with this? Okay, I'm going to ask you one, and you don't need to write it down because you actually know how to do it. I just want you to think about it, okay? If Myers walks at a heading of 197 degrees, okay? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Where am I walking? In which quadrant? Quadrant 3, because it's between 180 and 270, yes? So I'm walking down here. I'm walking at 197. This is 180. I'm at 197. So how far is this? I'm at 197. Straight south is 180. 17 degrees. Cool? And now I can do trig here if I need to using 17. But I could also do trig out here if I need to using what number? How far is this? $73, because this is 90 in total. Everybody cool? Okay, this is what we call a bearing or a heading. But it's also, you can also walk in a direction. And I'm going to show you what I mean by that. And again, I don't want you guys writing this down. I want you just to think. So if I told you that I walked, instead of a degree, now I'm telling you I am walking east 75 degrees north. What do you think that means? Because I haven't taught you. Read that, talk to your neighbor, see if you can figure out what direction you think that means. And you don't need to write any of it down because it's all just northeast, southwest. All right. So where do you think I am walking? I'm going to draw the numbers again. Quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Where do you think I'm walking? 1. I am in quadrant 1. Excellent. Why do you think that? Because it says I'm starting east and then I'm doing something north, right? So if I was walking east, I would be walking straight this way, wouldn't I? But I'm not walking east, I'm walking 75 degrees north. So I moved how far to the north direction? 75. So there is where I am actually walking. And what is the angle I am walking at? There's the 75. Cool? So what if I told you I was walking south 81 degrees west. Where would you start the first line of the angle? Straight south. Absolutely correct. But I didn't walk straight south, did I? I walk 81 degrees west. Which direction is west from south? Out here, how far? 81 degrees. So I'm out here at 81. Get it? That's also 19 or 9 in here, isn't it? So it's also west 9 south, isn't it? Because I could have gone west and then adjusted 9 degrees to the south and I'd be on the same path. Is everybody cool with directions? Yeah? The first one is where you start. The second one is where you adjust. Got it? Okay. That should help you with number 8. Okay. Now, the other thing about number 8 I want to point out is that the photocopying is crap. It doesn't look good. So we're going to slide down to number 8 here. You can't see the line very well. But this Curtis point is right here. This is Curtis point. Okay, there's a line there. It's just a little hard to see on your guys' photocopying. Okay? And all the rest of the points are written right by him. This is Fernie Island. This is Cole Island. This is Roberts Point. This is Armstrong Point. And this is Kingfisher Point. So when you read these two questions, you're going to find you can draw triangles on the map. Okay? Remember, what direction is straight north? That is 0. And we go up by going that way, yes? Everybody good? Okay. So now everybody has something to do. You're either finishing what I told you to start yesterday, or if you finish that, you're working on number 5 and number 8. Okay? And that's where we're going to go to today. Now listen to me. I warned you guys of this on Monday. I have a doctor's appointment on Thursday. A specialist appointment. I'm not going to be here tomorrow. So remember how yesterday I left with Mr. Kleisinger. I wrote it on the board. You could do some pages in your blue book. That's what I want you to work on tomorrow. Huh? I don't think we should have the test tomorrow. I don't think you guys are ready for it. But we do have to have it. I don't want you to take 2 weeks off either, though. We got to write it Friday. Okay? I mean, that's my opinion. I think you guys need another day of practice, but I don't want to give you 2 weeks off and then expect you to write a test when you get back. Because when you get back, I'll need to take 2 days to go over this again, and then we're going to lose 2 days then. And I don't want to get to the end of the year and be stuck for time. Understand? So normally I wouldn't like to do a test on a Friday, and especially not the Friday right before spring break. But I don't really see an option. Unless you guys feel ready and I can give you your test tomorrow. Don't overwhelm me with responses. You know I'm not going to actually listen to a vote, right? But it will help shape my thinking, maybe. I will still make the final decision, regardless of the majority. How many people couldn't care less? You're going to write the test on Thursday or Friday. How many people really don't care? Great. Okay, how many people want to write it on Friday? Everybody else wants to write it tomorrow? See, Kirsten, that's why I can't do votes. Because you guys are so lazy, you can't even vote. The one vote that got people to put their hand up was the one that says, who doesn't care? Everybody wants to say they don't care. Who cares? And you wonder why I get angry with you guys. Right? So what the hell's the point? In case you're watching along at home, I just asked 30 kids to put their hand up, and 4 did. You're writing your test Friday. Tomorrow I'm leaving you an assignment. You can work on it with the sub.